girls, we hope to reach all the schools that have logged in today. Most welcome for this session. Our presenter for the day is Madam. Yes, Madam Biko is the presenter of the day, and we expect to have the very best. Most welcome. Thank you. God bless all of us.
I think we are set. We have some 7 more minutes by Madam. We can start. I think we need to remove the yes, because you are alone. The social distance there.
To the sub-account director, the principal, the technical team, teachers of Mombod girls, and the girls. Good morning.
Good morning.
Yeah. Mrs. Ndiko, as you have heard, I'm going to present Physics Paper 2. I'm going to present Physics Paper 2, as you are aware. So I think we can start. For physics, we have 3 papers, just like any other science. We have paper 1, paper 2, and paper 3. Paper 1 and paper 2 each contains 2 sections, section A and section B. Section A carries 25 marks, short questions, a maximum of 3 marks, while section B carries 55 marks, structured questions.
As for physics, we have the topics divided. We have topics for paper 1 and we have topics for paper 2. For me, we have the paper 2, so we are going to start by seeing the topics for paper 2. I'm sure you know the topics learned from Form 1 up to Form 4. So we are going to have the topics for paper 2, and those are the topics for paper 2. Starting from Form 1, we have the first topic, that is linear propagation of light and reflection at plane surfaces. We also have reflection of curved mirrors, that is in Form 2, and diffraction of light and in lenses. The topics, I've tried to group them the way we can have the structured questions in section B, because we can have a question learning from linear all the way up to beam lenses, the structured questions. Then we also have the cells and the simple circuits, that is Form 1, current electricity Form 3, heating effect of an electric current Form 3 also, and mains electricity Form 4. All those deal with electricity. So we can have the structured question carrying all through from along those topics. We have electrostatics of Form 1 and electrostatics of Form 3, that is electrostatics 2. We have waves 1 done in Form 2, waves 2 done in Form 3, sound Form 2, electromagnetic spectrum Form 4. Magnetism, magnetic effect of electric current, those are Form 2, and we have electromagnetic induction Form 4. Photoelectric effect Form 4, cathode rays and cathode ray tubes, that is also Form 4. X-rays, radioactivity, and electronics from 4. So those are the topics which are tested in paper 2. So as you revise for paper 2, you should make sure you revise on these particular topics. The rest are in paper 1. When it comes to setting of the questions, we have, I've tried to group them, we have at least 5 different types of questions which can be set in the exam paper. We have the statement questions, numerical questions, graphical questions, diagrammatical questions, and then we have questions, experimental procedure questions. We are going to do each one of them, seeing what is required for each type of the question. Remember, these questions can be in section A or also in section B. So we start with statement questions. For statement questions, these are questions whereby you will find the words explain, list, name, divine, state, or you can also be taught to arrange, like the electromagnetic spectrum. Those are questions to do with those words. We have an example like of 2013 paper 2. We have an example of 2013 paper 2, question 1, a statement question. The question was said, state the reason why when a ray of light strikes a mirror at 90 degrees, the reflected ray travels along the same path as the incident ray. We have the answer or the expected answer. We know the angle of incidence equals to the angle of reflection. But now here the reflected ray follows the same path. So in a marking situation, not just the angle of incidence is equal to the angle of reflection, but you have to specify that the angle must be 0. So like this question, 0 was the marking point. If you don't give the angle of incidence is equal to the angle of reflection and you mention 0, then there is no mark. So 0 had to be mentioned. That's why the deflected ray will follow the same path. When stating factors, we have questions whereby you are told to state factors. Like we can be told to state the factors which affect the capacitance of a parallel capacitor. 2 of them. If we are told to state 2 factors, then state or restrict yourself to the number of factors or characteristics which are required. And then state the factors without explaining. You also avoid contradiction when you are answering. For example, like if it's characteristics of an image, the image cannot be real and the same time virtual. So you have to avoid mentioning the 2 words when mentioning, otherwise you will contradict yourself. Also, if the image is enlarged, cannot be diminished. So when we are stating, we should try to avoid those words to contradict ourselves. When we are dividing terms, this is also in the statement questions, dividing terms or principles, then the keywords must be used. Don't use the same word to define itself. The meaning must come out clearly. The laws and principles must be stated the way they are under the conditions which they operate. For example, if we are to state the Ohm's law, we have to give the condition under which the Ohm's law must operate. That is, when the current passing through a conductor, the current is directly proportional to the PD across, provided the temperature and other conditions are kept constant. So we have to give that condition. The same will also happen when we are stating the law of conservation of momentum for a system of bodies. The linear momentum remains constant, provided no external force acts. So the condition must be named. If you don't give the condition, then there is no mark. The same when we are also stating the laws, like the Archimedes principle. When we talk of the Archimedes principle, just an example, then we have to use the word fluid, but don't be specific. Don't mention water or liquids. You have to mention the word fluids. So that is when we are stating the laws and the principles. We also have a case whereby we can be taught to distinguish or differentiate between two things. For example, we can be taught to distinguish or differentiate between mechanical and electromagnetic waves, fission and fusion. If we are giving the explanation, it must be continuous. And if we are when we are also given two similar things and we are to differentiate them, we have to use a comparative term. A comparative terms, these are terms like greater than, more than, less than. For example, we have this question which was there on 2018. State the reason why thick aluminum wires are preferred to copper wires for transmission over long distances. Can I have somebody to give me the reasons? What is the reason? Hands up. Okay, when we are giving out the reason, here we are comparing aluminum and the copper. And because we are comparing the two of them, then a comparative term must be used. For example, aluminum is lighter than copper. You don't say aluminum is light, but the word lighter must be used. Aluminum is cheaper than copper. Aluminum lasts longer. We are comparing aluminum in comparative to copper, so we have to use the comparative term. State one characteristic of soft X-rays that distinguish them from hard X-rays. We know all about soft X-rays as well as hard X-rays. Soft X-rays, if we are giving the answer, like here, a comparative term must be used because we are comparing soft X-rays and hard X-rays. Soft X-rays have longer wavelength than hard X-rays. If it's the frequency, we have soft X-rays have higher frequency, have lower frequency than hard X-rays. So when we are comparing the two, a comparative term must come out. You don't use a comparative term, no mark. We have also in the statement question, we have compare and the contrast. This whereby we can be giving difference between two similar pictures. For example, we have the eye and the camera. When you are giving the difference between two pictures, then you compare a similar thing. Like if it is the eye, we are looking at the lens, the crystalline lens. Then for the camera, we also look at the lens, which is also used there. We look at it, the comparison, looking at two, the similar thing or the picture which is common in the two things. We also have the term explain, which is also used. When you are explaining, you can be taught explain the observation. If we are taught to explain the observation, then you give a schematic and detailed account of something. For example, we have this question. This is a common question. It appeared in 2012. It was there also last year. It was also early 20s. It's a common question if you go through the familiar. We have two identical copper coils, X and Y, placed close to DC supply, while copper wire is connected to a galvanometer. The question is, explain what is observed on the galvanometer when the switch is closed. For math. Explain what is observed on the galvanometer when the switch is closed. When we are explaining, first, you have to give the observation. What will be observed? You cannot go ahead to explain when you have not given the correct observation. If the correct observation is not given, then the examiner will not even go ahead to read what is written there next. Like this question here, we have the galvanometer deflects momentarily. The galvanometer deflects momentarily. Or you can say the galvanometer deflects and returns back to zero. The galvanometer deflects and returns back to zero. That is the observation. Then after the correct observation, then you can go ahead to give the explanation. So we have the explanation. The observation will carry 1 mark. Then the explanation will carry 3 marks. So when the switch is closed, the current increases to maximum. The magnetic flux in coil X dealing with coil Y will also increase to maximum, and this induces
an EMF in coil Y, which will cause the current to flow, and the galvanometer deflects. A question like this one, the first thing which the examiner will do is to check whether the observation is correctly. The observation can come at the beginning, or it can even come at the end. You can explain, and at the end say the galvanometer goes back to 0. That is to say the galvanometer deflects, then you give the explanation, and at the end, the galvanometer goes back to 0. So like this one, when it's being marked, first, the examiner will check, we are the word returning to 0. If you don't mention returns to 0, then the whole question will not be marked. In other words, it is called 0 in the question. So the correct observation must be given. And here the keyword was explained. That's why we have given a detailed explanation of what was happening. But if it was just state, like 2012, the question was just state the observation in the galvanometer when the switch is closed. State the answer was the galvanometer deflects momentarily, or the galvanometer deflects and returns back to 0 without explanation. But if explanation is there, then you have to go ahead and explain what is happening, or what is making it behave in that manner. We have number 2 of the question. State what is observed on the galvanometer when the switch is open. We have the answer. The galvanometer deflects in the opposite direction. If you look at these two answers, in the first question, the student was not specific to which direction the galvanometer was deflecting. That made him or her to be safe. Because the answer says the galvanometer deflects in one direction. The question were not concerned with whether to left or to right, though we do not want. But in this case, if the galvanometer went in one direction, then the second question, when you close the switch, when you open the switch, the galvanometer deflects in the opposite direction. And then it returns back to 0. The word returning back to 0 must be mentioned. The third question was asking, state what would be observed if the number of turns in coil Y is doubled. We are comparing before the coils were doubled. So like in this case, a comparative term must be used because we are comparing two things. Before the number of turns were added. So the galvanometer or the deflection in the galvanometer doubles or increases, or you can say becomes greater. That shows it will be greater than it was at the beginning. So a comparative term in that case is important. We have the second types of questions, the numerical questions. The numerical questions. When it comes to the numerical questions, all working must be shown, no matter how simple they might be. If working is not shown, then you might not score a mark. When you are writing formulas, the correct symbols must be used. For example, we have this formula which is normally an issue in paper 2. Frequency F is 1/T. It's good to take note when you are writing F.
it must be a small f, not a capital F. If you use a capital F, then it's wrong. So you have to use a small f. After writing the formula, proper substitution with the correct units is done. Then it's also important to know the formula. When we are writing a formula is an equation, but not an expression. So don't give one part of the formula. It's good we give all of it. Then it's also important to note that answers should not be expressed in fractions unless required. Answers should be expressed in 4 significant fingers or at least 2 decimal places. An example of where we can have an answer expressed in fraction is like in the transformers. You can be asked to give the ratio of the number of turns in the primary to the number of turns in the secondary. In that case, it must be a ratio. But unless a case like that, any other answer which is calculated must always be left in decimals, leaving 2 decimal places or giving the answer at least 4 significant fingers. When it comes to a question of 2 marks, the formula or the working is awarded the first mark, then the other mark goes to the answer. If we have a question involving 2 formulas, then the mark is awarded to the final formula or the formula leading to the mark, and then the other answer will go to the other mark will go to the answer. For a 3 marks question, the first mark goes to the formula, the second mark goes to substitution, and then we have the last mark going to the answer. When giving answers, the answer must have correct units. If the answer has correct units, it earns 1 mark. An answer with the wrong units, no mark. An answer with no units will earn half a mark. Will earn half a mark. That means it is better to leave the answer without units if we are not sure of the units, other than writing the wrong units. Because you end up by scoring half a mark, which might be at the end be of beneficial. In the case you give 2 answers, this one is treated as a contradiction. So you have penalized a mark. If you give 2 answers, leaving for the examiner to choose which answer is correct, you will be subtracted a mark. We have what we call error transfer in physics. Error transfer. This is whereby it encourages candidates not to leave any questions unresponded, especially where we have subsections. If we have a wrong answer in the earlier section, that wrong answer and it is used correctly in the subsequent section
then you'll end up by earning all the marks. For example, we have that wave which is drawn there. From the wave, you can get the period. We have the question. Determine the frequency of the wave. Then after that, we have to get the velocity of the wave. So if you are getting the frequency of the wave, I hope you had drawn the wave, you had seen the way it was. So like the first part was to calculate the frequency of the wave. So from the wave, we have T. We have T, we have okay, we have the period T from the wave was 20 seconds. Was 20 seconds. Let's say a student, instead of getting 20, assumes the period was 10. So uses T as 10 instead of 20. And comes ahead and says F is equal to 1 over T. That is the formula. Substitute F is equal to 1 over 10. That was his period. This ends up giving or getting 0.1 as. That will be the frequency. This question was 4 marks. So the student will get the answer wrong, but he will get a mark for the formula. That's 1 mark. Because the period was wrong and the calculation was wrong. But we have the subsequent question part, which was asking the frequency, the wavelength, the velocity of the wave. So we come and now use this answer, 0.1, in that other question. That other question was 3 marks. That first part, you got 1 mark for the formula. But now the second question, velocity, velocity is equals to lambda f. Velocity will be equal to, we are calculating the wavelength because we are given the velocity. The velocity was 20 meters. So we substitute the velocity, which we are given. We are given the velocity. (200) which will be equal to, I want to see that as a question actually. Yeah, I want to see the question. Then we go back there. Try it again. Yeah. Back. So the wave was 20 meters, and we had to determine the wavelength. We had gotten a wrong answer, which was 0.1. So we substitute the velocity 20 is equals to 0.1 times the wavelength. The wavelength will be 20 divided by 0.1. That will end up giving us 200 meters. The correct answer was supposed to, the correct frequency was supposed to be 0. If the period was 20, the correct frequency was supposed to be 0.05. So if we substituted the wavelength, the velocity 20, the frequency 0.05 times lambda will end up by giving you the wavelength as 400 meters. But this student got 200 as the answer. So you'll get all the marks. A mark for the formula, a mark for the substitution, the wrong answer, and then a mark for the final answer. That's what we call error transfer. Especially questions in transformers, whereby there are several subsections. It is of beneficial to the candidate, because if there were 3 more subsections and the first section was probably asking the current, that is in case of the transformers, you'll only miss 1 mark for the first part, but all the other parts will get all the marks. So when it comes to error transfer, that's what it means, and it is of help to the candidate.
On the numerical questions, we also have the issue where I say we give the units. When we are giving the units, like let's say we have calculated like here we have calculated the wavelength. We know the units are supposed to be, the wavelength is supposed to be 200 meters. When we are writing the meters, it's good to use the correct symbol. For meters, we know it's supposed to be small m. We have the third types of question, the graphical questions. Graphical questions. It's good to note that in the theory papers, both paper 1 and paper 2, we have no drawing of graphs. Graphs are only drawn in the practical paper. The graphs will be drawn for you in the theory papers, but it's for you to answer the questions from the graph. When we are answering the questions from the graph, then the reading should be from the graph. And there must be evidence to show clearly the graph was used. When it comes to the issue whereby the graph is a straight line, then for the straight line graph, then we have to relate with the general equation, that is y is equal to mx plus c. Then when we are working out the gradient, it's good to note that we have to remember some of the factors which might be written on the axis, like given 10 power 14, like we have this example on photoelectric. This is a question which was there in 2018. The graph seemed to have a problem, but to the examiner, there was no problem. When you look at the graph, the zero was not indicated in the graph. And from where we have those two, the vertical and the horizontal lines joining, where 2 is, there was only 2 divisions. Then from 2 to 4, there were 3 divisions. I'll try to make it, I hope you can see it. From 4 to 6, we have also 3 divisions, meaning the 3 divisions there, each one of them is 2. But from the start, we have no divisions for 2. So here the argument was that nobody said the graph is starting from the origin. In other words, what I'm trying to say is, when we are doing the exam, you will find a question and see as if there is a problem. Remember, those problems are taken care of. The problems are taken care of. So just read what you can see from the graph and work out that particular reading. Like this question here, we have the frequency multiplied by 10 power 14. The kinetic energy also is multiplied by 10 power 19. The question was to calculate the flux constant H. From the formula, when you write the formula, that is the Einstein's equation, HF is equals to what? HF naught, that is work function, plus kinetic energy. We make kinetic energy to be the subject of the formula so that you can compare it with our equations. So we'll have kinetic energy will be equal to HF naught over E minus HF over E minus work function over E. So the gradient is equivalent because we are plotted, the graph is plotted of kinetic energy against frequency. The gradient is H over E. When it comes to the calculation of the gradient, because we have to calculate the gradient, then we get the change in Y over change in X. That is change in kinetic energy divided by change in frequency. But now, it's important to note that when we are calculating this change in kinetic energy, remember the change must be multiplied by 10 power 19. And also in the denominator, the frequency will be times 10 power 14. And then you work out. If you just get the fingers without the powers, for example, you write 3 minus 1 divided by the change in the corresponding change, which might be 4, which might be 6 minus 4. And you don't write the numbers times 10 power. The numerator 10 power 19, in the denominator 10 power 14. Then at that point, the answer is wrong. The examiner will not continue marking. Some of us subtract, and then after that, they now start writing the power. That stage whereby you are calculating the gradient, the powers must be seen there. So it's good to be very careful when we have the powers, the axis, the quantities multiplied by some powers of 10. Let's take note of that. When it comes to the second part of this question, the question says, calculate or determine the threshold wavelength given the speed of light. C is equals to 3 times 10 power 8. We have the formula that C is equals to lambda 0 times F0. And from there we can get lambda 0, lambda naught, which will be C over F naught. When it comes to writing of this formula, the formula here we are talking of the electromagnetic radiations. So the letter C must be used when you are writing the formula. If you don't use C in the formula, like you write the general formula for waves, V is equals to lambda F, then you will miss a mark for the formula. So it's good to differentiate when we are talking of the speed of light, we must use C. But in these other questions of waves, then we use the general equation for waves. That is V is equals to lambda F. So it's good to note that. From there, we have the fourth types of questions. The fourth type of questions, diagrammatical questions. These are questions which involve graphs or diagrams. Or you can be taught to sketch a graph. Like sketch a graph to show an object falling in a fluid. Or to sketch the graph. When we are sketching, then label the axis. We also have these other types of questions whereby you can be given a diagram, like the C.R.E, the X-ray, or even the generators, the AC and the DC. You can be taught to name a particular part, then you state the function of that particular part. We also have the lay diagrams. When you are drawing the lay diagrams, then it's good to note that the lines must be drawn using a ruler or a straight edge, and they have arrows. If you don't indicate with arrows, then those are just straight lines. So the lines must be drawn with a straight end. If it is in the case of the magnetism, knowing the magnetic fields, then it's good to make sure they don't overlap. It must be drawn clearly. On the line diagram, you can have a question, an example of a question. The figure
Below shows an image of an object on the principal axis in a convex mirror. On the figure, draw a ray diagram to locate the object. When we are drawing the rays here, we have the part whereby the rays must be drawn with broken lines. That is the rays are vacuum. When we are drawing the rays, if they are real, it must be continuous. If they are vacuum, then it must be broken. So here we have a convex mirror. So we are given an image and we are to complete the day diagram. So we know from curved mirrors, we have when a ray which is parallel is reflected, divergence, and divergence appearing as it is coming from X. So if we add the reverse, then this one
would have been parallel, whereby they diverge. then where the two meet is where the object will be formed. In this case, if you look where the two are meeting, the same happens if it was the object and you have to draw the event. They are meeting at a place where the rays meeting their lead. So the object will draw and show it upright like that. When it comes to this case, the arrows must be put in the lead part, not in the virtual part. In case you place your arrow in the lead part like that, like now this question during the marking, we'll look at the first lane, the one through F. I find the one through F is correct, you get a mark. The one through C, we have an arrow at the point where it's not supposed to be. So that one you get arrow. But now the object is correctly at the position where it's supposed to be. So you get a mark for the object. So you end up by getting 2 marks out of 3. So during the day, the questions whereby we have the lay diagrams, then each lay earns a mark, then the object or the image will earn the other mark. If the image is fractured, it must be shown with broken lines. If you draw it with a real line, a continuous line, you'll get 2 marks for the days, but you'll get wrong for the image. So it's good to note that when we are drawing the day diagrams. So for the day diagram, remember you use a straight edge when drawing. We have the next type of questions. Experimental procedure questions. These are questions whereby you are given the apparatus. You are given the apparatus, or you can be given apparatus and you are going to draw a circuit, like in electricity. When you are drawing the circuit, then you have to use the correct configuration of symbols. For the potentiometer, we know how to represent it in the diagram, the resistors, and so on. Then you have to check for the workability of the instrument. When we are connecting, like if it's the potentiometer, it's good to note that the potentiometer should be connected across whatever you want to measure the PD. If it's the ammeter, it must be connected in series. So if it's a question to draw a diagram on electricity, The first thing which the examiner will check is to see whether the potmeter is connected across or the ammeter is connected in series. If it cannot work, then no marks for that. When it comes to equations involving experiments, whereby you have to, it involves changing of variables, and then you record the observation, then clearly state how this will be done and how you will present the data, and then state clearly how you will analyze the data, whether it's through graphical or through calculation. Then if you have plotted the graph, then you need to compute the shape of the graph. Like if it is the Ohm's law, we will verify the Ohm's law. Then we have to conclude by saying the graph being a straight line through the origin, we can deduce out that the current is directly proportional to the voltage. When you are given apparatus, then use all the apparatus which are given and don't use your own apparatus, otherwise you'll be penalized. The role of each apparatus should be clearly stated. For example, we have this question of 2016, whereby the student was given those apparatus to draw a diagram, and by convex lens, a lens order, a lit candle, a white screen, and a meter loom. Draw a diagram to show how you would arrange the above apparatus to determine the focal length of the lens. So we have the diagram drawn as it is. You can see we have the candle, which was given. We have the lens, which was given. The lens order, which was given. The screen and the meter. So everything which was given is taken care of. Then we have the question whereby we are to describe the procedure you would follow. We have the candle, placed at a certain distance from the lens. The candle is the object. Then moving, or the distance between the lens and the screen is adjusted until a sharp image is formed on the screen. Here the marking point was a sharp image to be formed on the screen. Not just an image, but the image must be sharp. Then take two measurements that you would take. Of course, we know we are determining the focal length. So we need the distance between the candle and the screen, which will be our object distance. The distance between the screen and the lens, which will be our image distance. Those are the measurements which will be all our variables. So you have 2 marks for that, each a mark. Then after that, you are asked, explain how the measurements in Roman 2 above would be used to determine the focal length. You can try to use the formula that is 1 over f is equals to 1 over u plus 1 over v. And from there, you compute f, making f the subject of the formula. You can still decide to determine F by drawing a graph. You can do a graph of 1 over V against 1 over U. We expect to get equal intercepts, then we get the reciprocal to get F. Or you can even calculate the magnification, do a graph of magnification against the image distance and calculate F. All those answers, all those working which can be done, they are taken care of. So use all the apparatus which you are given and don't use your own apparatus. Then analyze or get the correct measurements and then you answer the question. Those are the 5 types of questions we can have in a physics paper. Statement question. The second one is numerical question, graphical question, diagrammatical questions, and finally, experimental procedure questions. And with that, I think we come to the end of my presentation. So I ask or I give time for the questions.
Okay. For the question and answer session, if you have a question, we're just going to begin the process to give you. You'll just come in front of your laptop and ask your question from there. Okay? Yes. So whoever has a question can come and ask our question. Before we go to the other schools.
Questions?
Anyone with a question? Okay, as you prepare yourself, we can go to the other schools, okay? Yes. Okay, we are going to start with the Katelembu Center of Excellence. Katelembu Center of Excellence, kindly unmute yourselves, then ask your question. Katelembu Center of Excellence. Katelembu Center of Excellence, be more audible.
Morning.
Morning to you.
My question is, what are the penalties in this paper?
Pardon, can you repeat your question again?
What are the penalties of this paper?
Okay, mute your microphone.
The penalties for this paper is, as you have had, one penalty which you can be given is when you give the answer wrong unit, you are penalized. You are not given any mark. That's a penalty. In case you give 2 answers, you are also given or you are penalized 1 mark. Otherwise, when we are marking as examiners, we are normally for the student. We don't furnish the student with some of the things like spellings. Physics, we don't really mark spellings, but provided the word comes out clearly, wrong spellings will be awarded. Like we had last year, a question which was concerned with gamma, whereby we have the gamma used for killing of the cancer cells. Some of us could not write the letter cancer the way it's supposed to be written. They will have also the influence of the mother tongue. But provided that word comes out clearly, it does not bring any other meaning, you are given a mark. But if it brings a different meaning, then you are penalized. Otherwise, when marking, we really don't have those much penalties, but when you express your answers correctly, correct working, using your calculator, then you are awarded all the marks.
Okay, we are going to have a question from Iluvia Secondary School. Unmute your microphone and ask your question. Yes, Iluvia Secondary School.
My question is, when you have already calculated and you have cancelled and calculate using another method and you get a different answer, will the examiner mark the two methods, or he or she will mark the method which you have not cancelled? Thank you.
Okay, kindly mute your microphone.
Okay.
Kindly, Iluvia, mute your microphone.
Cancelled work is not marked. We mark the work which is not cancelled. So if you did a question and cancelled and it was a correct answer, marks on you. That question, all those marks, that work would not be marked. But the wrong answer which you did is the one which would be marked. Probably you'd get the mark for the answer, for the formula, but the cancelled work is not marked. The other thing, if you cancel and you go to do a working at a different place, not below the question, please, it's always good to direct the examiner. Number 17 is at the back of the page, because when marking, we go through the wood paper from the cover page to the bottom. So if the working is at the back, it's also marked. The key thing is direct the examiner. This number 1 is at the back because you might have cancelled. Otherwise, the cancelled work would not be marked, but we'll go to mark where you have done the correct working.
Okay, let us get a question from, there is a question from Ngomeni Secondary School. They are asking, if you are told to state and you explain, are you penalized?
If you are told to state and you explain, provided the statement, if it was an observation, came out clearly, then you'll get the mark for the statement. Otherwise, the explanation would not, because if it was state, probably it was only 1 mark. So the mark would just go for the correct answer, that other working would not. Like this question which I gave of the 2 coins. I said the question was explain. Of course, first you have to state the observation, then you explain. So if you explain and you have not given the correct observation, as I said, first, the observation is what was checked. You indicate the galvanometer deflects and goes back to 0. I said you can start by explaining and give the observation there at the end. We have to check first for the observation, whether it's at the beginning, whether it is at the end. So if the question was checked and you explain, we just look for the mark which was required to be given for the statement.
Okay, there is another question from KCSE Secondary School. They are asking, what is the penalty for giving wrong units?
No answer, no mark.
There is another question from Katelembu Center of Excellence. They are asking, which topics should we put more stress on?
All the paper 2 topics. Any topic can be tested.
Okay, there is another question from St. James Secondary School. They're asking, in relation to grading, how are the grades awarded in relation to the average figure scored? A range B, range
A range, B range, and such. Elaborate on that, please.
The grading comes after the 3 papers have been marked. As for paper 2, after marking, we enter the marks to the score sheets. Then paper 1, they also do so. Paper 3, they also do so. Then when the 3 papers are combined, then is when the grade will be given. But after the marking, we give suggestions according to how the paper was performed, where we think the grade A can start from.
Okay, let us get a question from Iluvia Secondary School. Kindly, Iluvia, unmute your microphone and ask your question.
Hello.
Yes, go on. Iluvia, you can ask your question. Iluvia Secondary School, you can go ahead and ask your question. Iluvia Secondary School. Iluvia Secondary School. Okay, let us have another question from Vota Secondary School. Vota Secondary School, kindly unmute your microphone and ask your question.
Okay, my question is, what if you are drawing an array and behind the mirror, you use full line, you don't use dotted?
Pardon, can you repeat your question again?
Is that, you don't, I'm asking whether when we draw an array of light and behind the mirror, we don't use dotted lines, what is the penalty? Is it that the answer is wrong, the whole answer?
Okay, thank you. Mute your microphone.
For the lay diagrams, normally a question is 3 marks. Because to locate and then the image will earn the other mark. If the relays, you have drawn all of them continuous when it was supposed to be broken at, that is behind the mirror, then you'll miss the 2 marks for the rays, as I've shown in the example. But if the image was correctly drawn, but remember, if the image was made by virtual rays, it must be also virtual. If the image is real, it must be real. And that is when it is formed by real rays. So if you draw the rays continuous or through, and the image you also draw it continuous, you don't get a mark. But if the image was correctly, then you can get the mark for the image, but miss the marks for the rays.
Okay, let us get another question from Changuli Memorial Secondary School. Changuli, unmute your microphone and ask your question. Changuli.
Yeah, my question was, if you are told to state and you find yourself stating half the statation, will you be given half a mark or?
Thank you, Changuli. Kindly mute your microphone.
When you are told to state a law and you don't state it completely, as I said, you must give the condition under which it works. If you don't state it completely, no mark. We don't give half marks in physics. We only give half a mark penalized when we are giving a penalty for no units. That's the only time there is half a mark. Otherwise, in the other marking, it is either a correct answer or no. There is the key point which the examiner is looking for. If the examiner does not see the key point, then no mark. Otherwise, we don't say I have a mark, no, I have marks. Only for the answers without units.
Okay, let us have another question from Kamudanga Secondary School. Kamudanga, kindly unmute your microphone and ask your question.
Yes, I'm Noah from Kamudanga, and my question comes from the chapter of gas laws. And is there any difference between the definition in gas laws in physics and in chemistry?
Please, we are dealing with the paper 2. Gas laws is in paper 1, but the definition of the laws are just the same.
Okay, we are going to get another question from Kidimani ABC. Kindly, Kidimani ABC, unmute your microphone and ask your question.
Okay. My question is.
Yes, Kidimani.
Hello?
Yes, we can hear you.
My question is if you draw your diagrams using a pen and you are correct, are you penalized?
Okay, thank you. Mute your microphone kindly.
You are not penalized. You are only penalized if you are supposed to use a ruler and you don't use a ruler. Otherwise, whether you draw with a pencil or with a pen, we still mark. But the only thing is, if you draw with a pen and then you make a mistake, you might end up by your diagram being untidy. Otherwise, the key thing is to know if a ruler is to be used for the diagrams, use it. You use your free hand, no mark. It must be a straight line. Otherwise, no penalized for using a pen instead of a pencil.
Okay, we are going to get another question from Muvuti Girls Secondary School. Kindly, Muvuti Girls, unmute your microphone and ask your question. Muvuti Girls, kindly unmute your microphone and ask your question. Kindly, Muvuti Girls, we cannot
How
get
is
you clear.
parallel working? A question, how is parallel working treated when marking?
Pardon, repeat your question once again.
How is parallel working treated when marking?
Okay, thank you. Mute your microphone.
Another question.
When we have two parallel workings, we mark the first work, the one which comes first. If it's a paper and we have the first column, that's the work which will be marked. But if you give two answers, then you will end up by being penalized. A mark for the answer.
Okay, Muvuti Girls, you can unmute once again and ask your second question. Muvuti Girls.
If for instance you have forgotten to write your formula and then your working is correct, will you be penalized?
Okay, thank you. Mute your microphone.
If the substitution is correct and the formula is not there, then we assume the formula is implied in your substitution. So if the question was 3 marks, you'll get the 3 marks. But the only problem is if there was no formula and you make wrong substitution, you don't get a mark. But if the formula was there, you can get a mark for the formula. That's why it is undivisible. Any question, start by writing the formula. You can make a mistake in the substitution, but you can score a mark for the correct formula. Otherwise, if you are sure, then the formula is implied when you substitute. So you'll get all the marks.
Okay, let us have another question from St. James Secondary School. Kindly, St. James, unmute your microphone and ask your question.
There's a case whereby you have been told to state, let's say, state Ohm's law, and then instead of giving the statement of the Ohm's law, you go ahead and then give the formula for Ohm's law. What's the difference between the two? Are you penalized when you are giving the formula, or which is which?
Okay, thank you. Mute your microphone.
Stating must be in words, not in formula. So you have to state the law in words, not giving the formula.
Okay, let us have another question from Upper Kitanga Secondary School. Kindly, Upper Kitanga, unmute your microphone and ask your question. Upper Kitanga Secondary School.
I am Gabriel. My question is pertaining on the use of formulas. If you use two formulas on the same question, are there marks?
Okay, thank you. Mute your microphone.
As I said, if a question end up by being used to two formulas, the formula which is leading to the answer is the formula which earns the mark. The other formulas are treated as working. So the formula which is leading to the question, to the answer mark, is the formula which will be awarded a mark. The others are part of the working.
Okay, let us have another question from Illuvia Secondary School. Illuvia, kindly unmute your microphone and ask your question. Illuvia Secondary School.
What happens when you are given instruction like y is equals to 3.142, then you use 22/7. In the graph, you are told to draw a graph of kinetic energy against photoelectric. Then you get, the values you get is 0.1, then you multiply by 10, and you fail.
Okay, Illuvia, thank you. Mute your microphone. Okay, Illuvia, kindly repeat your question. Illuvia Secondary School. Illuvia Secondary School, kindly just type your question and I will answer you. Illuvia Secondary School, kindly type your question and we'll answer you. Okay, let us get another question from Katoloni Secondary School. Katoloni, kindly unmute your microphone and ask your question. Katoloni Secondary School.
Yes, my question was, to how many significant figures should I give my answers to? The second one, can one use diagram to explain questions? The third one, do they mark steps in physics like in mathematics or just answers?
Okay, thank you, Katoloni. Mute your microphone. Okay, Katoloni Secondary School. Kindly unmute your microphone once again and ask your question. Katoloni Secondary School, kindly unmute your microphone once again and repeat your question.
To how many significant figures should I give my answers to? That was the first question. The second question, can I use diagram to explain a question? The third question, do they mark steps in physics like in mathematics?
when giving the answers, answer must be given at least 2 decimal places. In fact, 1 decimal place is not given a mark. We just find an answer given in 1 decimal place, the answer marked not there. So answers, let's give them to at least 2 significant figures. Then I said fractions do not earn marks. We don't give answers in fractions. So in decimals and at least 2 decimal places. Diagrams, depending on the question, you can use them to explain yourself. And then for physics, if it is an answer is, a question is 3 marks. The first mark is just for the formula. The second mark is substitution. We expect you to use the calculator and give the final answer. So we don't mark those other steps. But we just, after correct substitution, we just go to the answer and check where the answer is correct, depending with what you have written. Like somebody asked about pi, you cannot write in the formula 22/7 and use the pi in the calculator, because I will mark with my own calculator and see whether I will get the answer which you got. So the answers will be marked. Remember, I also talked of the transfer of error. That might have not been the answer which is in my answer sheet, but I have to work out with your values if there was transfer of error. So I will work out with my calculator and see whether I get the answer which you have to earn all the marks. So steps don't mark, but we are only key with the formula, correct substitution, correct answer according to the calculator.
Okay. Kindly, you'll allow me, before we continue getting questions from the rest of the schools, let me get back to the host school and get their questions. I'm back to you. Can I get questions from you? Kindly. Are you ready? Do you have questions? Okay, you can just come in front of your laptop and just a minute before you proceed asking your question.
Hello everyone, I'm Shane Mutili. My question is based on experimental questions. We were given operators to drive a circuit.
Pardon, just a minute.
Hello everyone, I'm Faith Mutili from Nguni Girls School. My question is based on experimental questions. Given apparatus to draw a circuit. The question is, when you fail to are you bringing internet marks? Thank you.
If we are given the apparatus to draw in the circuit,
If you are given apparatus to draw the diagram, if you don't use all the apparatus, you are penalized for that. Because all those apparatus which you are given must be seen in the diagram. Then, depending with the diagram, like if we have on electricity, we are using or we are determining, we have verified the Ohm's law. You are given some apparatus there. We have to draw a circuit. You have the potentiometer, ammeter, probably a resistor, a switch. You are given those apparatus. Then you come and connect this potentiometer collectively across the conductor which you are given. And probably you forget to include one of the apparatus like the switch or even the ammeter. Because these students knows the potentiometer should be connected across. The question might have been carrying about 3 marks. 1 mark might have been for the correct connection of the potentiometer. So you will get that particular mark. But finally, you cannot get all the marks for the question. But if the question was just 1 mark for the whole diagram and then a apparatus is missing, then you will miss the mark.
Okay, can I get another question from another student?
From Numerical, when giving out your answers, can you give them in standard form?
Yeah, answers in standard form are marked, they are collected. Of course, there are some of the fingers you cannot express them even in decimals. Like if you were to calculate the Planck's constant, we expect to get 6.84 or 6, depending with the values you have from your graph, times 10 power negative 34. Even if it was times 10 power negative 2 or power 2, the answer expressed in standard form is correct. In fact, standard form is of good use. But remember, at least the answer to have 2 decimals or fingers, significant fingers for them.
Okay, another question? Another question? Have you exhausted your questions? Do you have questions? Do you have questions? Okay, I will go to the other schools, then I'll get back to you. Okay? Prepare more questions. Okay, let us get a question from Kasinga Secondary School. Kasinga, kindly unmute your microphone and ask your question. Kasinga Secondary School.
You have a question. When you are told to state and explain, and you state without explaining, will you have a mark or will you be penalized? When you are told to state and explain,
You'll get a mark for the stating, but for the explanation, no mark.
Let us have another question from Moore Farm Secondary School. Moore Farm Secondary School, kindly unmute your microphone and ask your question. Moore Farm Secondary School, kindly unmute your microphone and ask your question. Moore Farm Secondary School. Moore Farm Secondary School, kindly unmute your microphone and ask your question. Moore Farm Secondary School. Okay, let me move to Changuli Memorial. Changuli, kindly unmute your microphone and ask your question. Changuli. Changuli, kindly unmute your microphone and ask your question.
Yeah, my question was, you are told to verify a gas law, and provided you are given the diagram, will you give the observations made or the procedure given in the KLB book?
Come again.
We have another question.
Changuli,
Ask that one again.
kindly repeat the first question.
Yeah, my question is on verification of gas laws. Provided you are given the diagram, will you give the procedure given in the KLB or the observation?
The question is asking what?
Verification of gas laws.
The verification of the gas laws.
Yeah.
If we are told to verify, you have to give them the diagram. If you draw the diagram well, you can go ahead and show the measurements which must be taken of the variables, and then from there, the verification of the law.
Okay, we have a question from AIC Kimakimo Secondary School. They are asking, how is crossed work treated?
Crossed work is not marked.
Okay, we have another question from Chemudeke Secondary School. They're asking, kindly clarify again on statement questions, please.
Statement questions. This whereby you can be told to state the observation, give the correct observation. If we are told to explain, go ahead and explain what is observed. If we are told to state factors, give the factors required without explaining. If we are told to state, don't go ahead to explain when you are just told to state. But if it was explaining, then you go ahead to explain. An example of stating, we have 2018 question whereby was state 2 uses of microwaves. State 2 uses of microwaves. We only need to mention microwaves is used either for cooking, you can even say warming, or even eating, all those are the same answer. Don't explain how it is done. Micros can also be used for communication. Don't go ahead to explain, but just state what it is. But if it is explained, like we have the case I gave of the coils, then you have to explain how the magnetic flux will link with the other coil, and then we end up by having the EMF induced so as to have the current flow. That is now explaining. But stating is the observation that the galvanometer deflects momentarily. You have just stated. But now you go ahead to explain what is making this galvanometer deflect. Is because of the magnetic flux growing from coil X
octocoid Y as it was in the diagram. Then this leading to EMF being induced. Then we have current flowing. So that's the difference between stating and explaining.
Okay, we have another question from Moore Farm Secondary School. To minimize the words. Can an observation be summarized to minimize the words?
Yes. In fact, physics, we don't require so much stories. If it's a question, we only, if it's the question asks 3 marks, there is 3 things which the examiner is looking for. So you go ahead to explaining other things, then you might deviate from the correct answer. So if you can summarize your answer and give the point correctly, then you earn the mark. Okay. Like now here we are talking about the galvanometer deflecting momentarily. You have just summarized. You have made deflecting in one direction momentarily. You have made going and coming back. You have summarized that. But if you can put it clearly, it deflects and turns back to 0, no problem. But the answer or the key thing should come out clearly.
Okay, we have another question from Katalebu Center of Excellence. Is there a penalty if I apply the formula directly without stating it?
Without stating or without writing. I said if you don't write the formula and you substitute where you apply the formula where, the marks for the formula, they are bright in the substitution. So you'll get 2 marks, 1 mark for the formula because you have substituted very correctly, and then the other mark for the substitution, and then the final answer. But if you substitute wrong, then you get wrong. But if the formula was there, you can get a mark for the formula. Formulas are marked in physics.
Okay, we have another question from KCSE Secondary School. They're asking, while calculating the work function of a service, will you use the threshold wavelength or the y-intercept that you will take three threshold wavelength divided by the change of electron? Okay, I repeat the question again. While calculating the work function of a service, will you use the threshold wavelength or the y-intercept that you will take threshold wavelength divided by the change of electron?
If we are calculating the work function, and from the graph, probably there was no this negative part. The graph was just, we were just getting the threshold frequency from the graph. The graph was probably stopping potential against frequency. We will get the x-intercept as the threshold frequency. If we are to calculate the work function, then I will end up by using the work function will be given by the Planck's constant which you got in the upper question times the frequency or the threshold frequency. But if now you could extrapolate the graph and get the y-intercept, we know from the formula, the y-intercept gives us the work function. So if the y-intercept was negative 1.4, and you are asked to calculate the work function, straight away you just go and equate negative 1.4 is equal to negative W naught over E. So the work function will be, we multiply out E, the letter, if you are to give an electron force. So the work function will straight away come to 1.4 electron volts. If the question was 3 marks, you'll get all the marks, provided there is evidence you have used the graph. So it depends with how the question is, which formula you are using.
Okay, there is another question from Katalebu Center of Excellence. They are asking,
If the question has 3 marks, formula is a mark. If the question has 2 marks, the first mark can be given for the formula or for the substitution. And then the answer.
Okay, we have another question from Machakos Baptist. They are asking, when stating, are we allowed to use Romans or numbers?
Or stating factors. If we are allowed to state 2 of them, even if you don't even put the numbers, you don't, provided there are 2 of them, they are marked.
Okay, another question from Kathekakai Secondary School. They're asking, what is the penalty for getting a correct answer and failing to indicate the units?
The penalty is half a mark. The answer, instead of 1 mark, you are awarded half a mark for no units. But if wrong units, no answer at all for the answer.
Okay, we have another question from Changuli. They are asking, what if you write the correct answer but no units are you penalized?
Penalized are.
We go to Muvuti Boys High School. They're asking, a stone of mass 1.5 kg is weighed round. A stone of mass 1.5 kg is weighed round on the end of a string in an horizontal circle such that the angle suspended is 30 degrees and the radius is 0.8 meters. Find the linear velocity.
First of all, circular motions are in the paper 1. Though we are dealing with the paper 2, but for linear moment, for the linear velocity, it will be given by the angular velocity times the radius. So you start by calculating the angular velocity, then after that you multiply by the radius. But circular motion is in paper 1.
We have another question from Chambuko Secondary School. They're asking, if you have been asked to define a term and you instead use its formula, will you be awarded marks?
No. If you are taught to define a term and you write the formula, no marks. You have to give the definition in words.
Okay, we have several questions from Moore Farm Secondary School. The first question they are asking, when asked to state SI units, must it be in words?
If we are taught to state, it must be in words. We are taught to state, but if it's a question you are calculating the answer, then you have to give the units, and it's important to bring out this issue which came out last year, though at the end we try to ignore it. When you are giving the units, the question was to calculate the energy, work energy, the energy of a photon, and the energy was to be given in joules. The energy was given in electrons. In fact, it was the last number of the paper last year. That energy, it was given in electron volts. When calculating the energy to change in electron volts, we will multiply with the electronic charge. You end up by getting the energy in joules. Now, when you are writing the word joule, you use the symbol for joule is supposed to be capital J. But now here we had an argument whereby people were writing the word joule in words. But now when you are writing the joule in words, there was that kind of confusion, though at the end we settled the matter, but I'm sure this time it might become a problem. When we are writing the word for units, use small letters. It's not a noun. Like yours, you use a small j. But if you are writing the symbol, you use a capital J. The same will also apply any other units you are using.
Let's take note of that. It was an issue last year. In fact, people, only when we were coordinating, at the end, after we realized through the dummies, students were writing it in full words, we agreed, or it was agreed to be given a mark. But never know, this time it might be very strict. So when writing the units, and you are writing it in words, use small letter. It's not a noun. But if you are writing the symbol, use a capital letter. I hope it's clear. Otherwise, the units must be stated correctly the way they are.
Okay, there is another question from Water Secondary School. They ask, if you show your working and you don't show the formula, how is it treated?
If the working is correctly, you are given the marks. It's not a must to show the formula. The formula will be implied in the substitution, as I said.
Okay, there is another question from Moore Farm Secondary School. They're asking, do I get penalized for writing the wrong formula, but then submitting in the correct one, and I get the correct answer?
You are penalized for writing the wrong formula. A good example is on waves. This is a question whereby students are penalized. You are just given a wave drawn, and it's just probably sound. And then the formula we have, V is equals to lambda F. And you come and use C is equals to lambda F. C is for speed of light. This was not light. So this formula, you'll be penalized a mark if you use C. But now the other marks will get. In fact, that's a formula which is students are normally penalized. Let's make sure we know when to use C and when not to use C. C is used for the electromagnetic spectrum. Any waves in the spectrum. But another wave we are talking about, because we have different types of wave, then you have to use the letter V for the velocity.
Okay, we have another question from Gomeni Secondary School. They're asking, difference between current and voltage.
Voltage is measured with the voltmeter across, but current is used with the ammeter, and it's the rate of flow of changes per unit time from the definition. But voltage is the work done when one electron moves through a potential difference of 1 volt.
Okay, we have another question from Water Secondary School. They're asking, how do you show the working with recurring decimals without using fractions?
If it's a recurring decimal, like there was one question I can remember, you have to get the refractive index of water. You are given the real depth and the apparent depth. From the diagram, the formula is, the question was 3 marks. That is, refractive index is given by real depth of apparent depth, 1 mark. Then you substitute, the real depth was 4 centimeter. The apparent depth 3 centimeter. So you have 4 over 3. When you have 4 over 3, this will be 1.33. In fact, giving the answer as 1.3 no mark, but you have to give it as 1.33. Or you can even write 1.3 and you put the dot to show recurring. If it was 6.6, then you round off. You will say 1.67, at least 2 decimals. So you either put the recurring dot to show recurring, or you round off. That's what is accepted, but no fractions.
Okay, there is another question from Kamudanga Secondary School. They're asking, if you have been told to calculate temperature and its degrees are supposed to pardon, let me just repeat the question. If you have been told to calculate temperature and it's in degrees, are you supposed to change while calculating, or you are supposed to change in your answer to Kevin.
If the temperature is in decrease, it depends with what you are calculating. If it's the change, whether it's in Kelvin or in Celsius, you get the same change. But in questions of gas laws, whereby we have to use the absolute temperature, you work out with the Celsius, and at the end you insert the Kelvin, the answers are different. Because in Celsius, we have to add 273. So it's good to note what you are calculating, know whether to insert or to change earlier or to indicate at the end. If it was in the quantity of heat, you just need at the end indicate the Kelvin, because the change in temperature is just the same, whether in Celsius, whether in Kelvin. And then you can be penalized for stroke.
Okay, there is a question from Mua Farm Secondary School. They're asking, is it a must to round off values when writing to 4 significant figures?
Yes, it's undivisible, you loud no.
Okay. Okay, I'm back to the host school. I need to get more questions from you.
From the chat. Can you state no using formula?
It was answered. Yes. Just a minute.
Okay, my name is Maureen, and I was asking in experimental questions, maybe you're given the apparatus, and when you logically when you do the question, or when you apply the apparatus, you see there won't be the experiment won't work. Can you add apparatus? Thank you.
For example, that graph of indicating which had an linear scale, the first one is 2, the rest are 3. Does it imply we can draw? Let's say, for example, we start the first, the rest are 5, and we execute the 0. For example, let's say you're drawing a graph of kinetic energy against frequency. We know when you get to the work function, then implies the y-axis. Is that what work function to get?
Okay, to start with apparatus, if you are given apparatus for a particular question, the examiner knows those apparatus are adequate for that particular question. Don't add your own apparatus. Just use the apparatus which you are given. Go to last year's paper, you will see a question on magnetism, whereby a student were given some apparatus to determine which is a magnet, or determine which of the metals or which the conductors given which was a magnet. And there was a string and so on. The student has to show a string to tie the magnet that is allowed to swing.
so that you will always string with the north side. While all the other materials, even if they swing at a particular time north side, no way all throughout it will always swing north side. But the magnet will always swing north side. There the apparatus were given as swinging. We have to show trying out with the magnet, and then you are allowed to swing. So it's advisable to use the apparatus which you are given. Don't add your own apparatus, otherwise you will be penalized. The other question on the photoelectric, remember I said evidence from the graph is the key thing. Graphs will be drawn for you for the theory paper. No graphs will be taught to draw. They will always be drawn for you. What you need to know is, especially the application of y is equal to mx plus c is very important. To know whether what you want to calculate, you need to calculate the gradient or is it the y-intercept. Like if it is the work function and the graph was with the negative part and the positive part, and you are asked to calculate the work function. Instead of using the Planck's constant which you calculated and the threshold frequency, you can go ahead and use the y-intercept. You will get, and it will be even faster. You will get the correct answer. But if that intercept was not there, you cannot extrapolate. Then automatically you have to use HF not. Otherwise, no penalty. By the way, all the answers which a student can score are normally marked. And any answer which question which is done, there is normally a very wide range for the answers. So any answer which you can get using whichever formula will be accommodated in that particular range. I remember there was a question where it was on waves. A wave was drawn with 2 cycles. But now the problem was the first cycle was covering 5 squares, but now the second cycle of the wave was covering 4. And the students were to determine the wavelength. It was a period. You see, now here from the scale, one can decide to use this first cycle, another one can decide to use this second cycle. Another one can decide to use the time taken for the 2 cycles and then divide by 2. Or use it as a period and know it covered 2 waves. All those answers were accommodated for. So any answer which you can get, provided the working is correct, is normally accommodated in the marking. We don't just mark a particular answer, but we do what we call follow through the working.
Okay, can we get more questions? More questions? Just a minute.
Customer fake Mutindi. Yeah, my question is based on procedural questions. Well, I suppose like in things like this, you're supposed to explain the procedure. We're supposed to include the formula. Thank you.
Another question? Another question? Okay, I believe you can answer that.
The formula, of course, will come at the end after you analyze. You can include the formula to show. But if you are to verify, then you will first work out, and then at the end, you can now show the formula. But the procedure is whereby you have to show how you determine the variables. Because in any experiment, we expect to get some variables. So you have to explain how which variables you will collect. Then after that, how these variables will be used to verify what you want. Then after the verification, now you can include the formula. It depends with the question what the question is asking. If you follow out the question clearly, you will never get lost.
Any other question? Anyone with a question? I'm waiting for you to come and ask your questions. Thank you. Let's have more questions. Okay.
The teacher is an examiner.
Okay. Let's have one of you come and sit where our teacher was seated and address the other students in the whole sub-county. Tell them what you feel about this paper and whether you think that students are going to score 100%, which is what we want you to score. Okay? Come and speak on behalf of the others. Say your name.
Hello, everyone. Hello, everyone. I'm Faith Nzisa, Mumbuni Girls School, the host. Well, first of all, I'd like to say thank you to our coordinators of this program. It has really helped most of us. As physics students, Mumbuni Girls, I believe we have gained more as per what our teacher has always told us. We have gained even information on some things that we didn't know, on some corrections, on some parts that were not clear. So I'd like to say a big thank you to the coordinators. We promise to excel. We promise to join you in those universities. And my colleagues can testify that we are going to get those A's, that Mumbuni girls, we are going to shake this nation, that we are going to become those engineers, those pilots, and those wonderful lecturers in the universities. So to the rest of the schools, embrace this program positively, see it as benefit to all of us. Let us not make this work look like as if it's nothing. Let's change the grades for physics. Let's aim higher. Otherwise, I wish you all the best. God bless you.
I'm Veronica Muya, the principal of Luvia Secondary School. I'm impressed by the way the students are interacting with the examiners. And I want to encourage you to make us proud. We want to be the sub-county to beat in our county. In the past, our results have not been very impressive, but with this program, we hope to shine. And I'm encouraged by the girls here at Mumbuni Girls. They say that they are there. And all the schools, I know that will shine. This year, we want to generate more engineers, more students joining the universities. And I know with the support of your teachers, put the information you have got into the best use. For the remaining days before the KCSE, I know all is possible and we are all proud of you. Let us do our best to make our sub-county the best in the county, and we can even be in the best in the country. All the best, and let us remain focused. Okay, good afternoon.
Good afternoon,
Once more, we are here. I didn't say my name last time. My name is Karen Karuntimi, Principal Mumbuni Girls. We are happy for what we have done this morning. We appreciate Madam Josephine so much for the good work that you've done. And I'm sure all of you learners in our sub-county have benefited a lot in what you've been taken through. And it is upon you to continue revising on the hints that have been given so that we can continue to excel in this paper when it comes to KCSE. Remember, we are preparing for our final exam, which is coming in a month's time, and therefore we need to be properly ready for it. So I want to encourage every student to work to their best so that we can be able to excel as a sub-county. I'm the chair of the academic improvement in the sub-county, and it is my wish to encourage every school to improve as we set our targets at the beginning of the year, so that Machakos sub-county is no longer at the bottom, but comes at the top. And my word for each one of the schools is that we work to get the very best. We are breaking we are taking a break now up to 2 so that you can refresh and so that you can be ready for the next session.